Welcome back to Vex Isn't Scary. This is part 3, and we are going over functions. Now, in Houdini, there are many nodes that make our lives easier. You could retopologize a mesh and add beveling to all of the edges, or you could use the bevel node. In Vex, we have the same idea. You can do things the long way, or you could use functions. What are functions? Functions are pieces of code that you can call upon through the name of the function. They do a lot of work behind the scenes which you don't even need to concern yourself with. The analogy that I always use is that of a chef. The chef's job is to take a bunch of ingredients, follow a recipe, and then provide a completed meal. A function does the same thing. It takes some ingredients, known as arguments, then it follows some instructions or code, and then provides an output. You only need to give it ingredients. It does the rest. Different functions require different arguments. The arguments that a function requires can be found on the Vex documentation or in this tutorial. Let's begin. In Houdini, we can go ahead and begin as we usually do by dropping a geometry node. So we can drop a geo node and we can rename this to part 3 functions. Dive inside and let's start with a sphere. So drop down a sphere and a scatter node. The scatter node will just increase the points to about 10,000, maybe even 100,000. Yeah, that's cool. And then we can just drop an attribute wrangle. So AW, plug your scatter node into your attribute wrangle and set your display flag. We're also going to be using the timeline in this tutorial. So activate the real-time toggle because this will play back as fast as it can if you don't. So switch it on and we'll play back at 24 frames per second. Go back to the beginning over there, and then to our attribute wrangle. Now, where we left off last, we just touched on the set function. It looked something like this. We had v at cd equals set, and then we gave it 3 components for the vector. So if we wanted it to be blue, it would be 0, 0, 1, and then you put a semicolon at the end, right? Now this over here, in this case, we have this set function. Now, you'll notice that this is a function by the turquoise color that it has. And this is the same formula used everywhere in Houdini. You have the function's name, followed by round braces, and inside you have your arguments separated by commas. So arguments are, like I said earlier, just the ingredients. It's what it needs to run. So this requires 3 different arguments, and we know this because they are separated by the commas, 1, 2, and 3. What this one does is it takes the x component that we give it, the y component that we give it, and the z component that we give it, turn it all into a vector, and feed it into our color attribute. And I'm going to bring up my second monitor so you can have a look at the side effects documentation over on the website. So go to Vex documentation, Vex functions, and over here we can filter by set. And there's all of these, but the one we're looking for is down at the bottom under utility called set. And now, if we take a look over here, we have different types of the set function. You can see it says the set function has a wide variety of forms, allowing you to perform many different types of conversions. Now, we have vector 2, vector, vector 4, matrix 2, matrix 3, matrix. Now, we haven't gone over matrices yet, but matrices are basically extended vectors. They're multi-component, but they have more than 3 or 4 components. It's a bit more complicated than that, but that's the gist of it. Now over here, you can see that the data type that we're looking for is just a vector, right? Because color is a vector, so we're looking for this one right over here. And in this case, the set function takes these 3 arguments. And you can see that depending on what type of data type you want, it takes more arguments or less arguments. And so in our case, we just want these 3 components. That's very simple, right? Nothing too crazy over there. How about we give our points random colors? How would we go about doing that? Well, we know that we want to affect CD. So before we start anything, let's just press Alt-E to bring up our editor. We can expand it so that it's a bit bigger. Now, in here, we know that we want to affect CD. So we say v at CD, and that's lowercase, so v at CD, right? Equals. Now we're going to use a function. This function is the rand function. Make your brackets, and then we need to give it arguments. What type of arguments does the rand function take? Well, if you want, you can go over to the side effects documentation once again. All you have to do is filter by rand. So just type rand over there, and you can see this rand function. What does it do? It creates a random number between 0 and 1 from a seed. And as you can see, it gives you different types of data types, but all of them basically just take the same type of seed. We want a vector for color, and so the rand function takes a single argument, which is a float. Now, a seed is a value to generate a number from. A seed of 1 gives a different value to a seed of 0. But there's no relationship between the two values. A seed of 1 and a seed of, negative 58,340 can both result in similar randomly generated numbers. Keep in mind that rand generates a number between 0 and 1 based on the seed, and then you can work with that number. So let's give this a random seed. Let's just give it a value of 0.2 and see what it gives us. If we say apply and accept, you'll see that this whole thing becomes pink. So let's change this rand value, 0.21, and you see that it's a completely different color, right? 0.25, 0.29, each one gives you a different value. And so if you go 1, if you go 0, minus 15, right? It doesn't matter what the seed is, it will give you a different random value. Alternatively, this could be an attribute. So you could very easily say something like and then give it an attribute. And in this case, I'm going to give it an attribute that we haven't actually seen before. And that is the @frame attribute. Now that's a capital. So capital F, everything else is lowercase. And that will give us a random value per frame. So this frame just calls on the frame number that we're currently on. So on frame number 2, it's a different color. And as you can see, it's a different color every frame. Play that back, it just flashes. So now we have that. And rand will generate a random component for each of the components in your vector. So that's pretty cool. Now, what happens if you would like to have a random color per point? This is something we haven't really done yet, which is working on per point calculations. And this is where something very useful comes in, which is called @ptnum. It's an attribute that Houdini generates for you, which is the currently processed point number. And this is an important concept to grasp. We use this a lot. This is a unique identifier of points in our geometry. It can be used to do per point calculations. When we call things like @p or @n or @cd, those are attributes which correspond to a point number or ptnum. When Vex code is executed, each point gets processed, and as it processes each point, it uses @ptnum. So if we say something like if @ptnum equals 5, then make it blue, Houdini runs over all points, and for point number 5, it will make it blue. What we can do is in here, we can replace this @frame with something like @ptnum. Now we have a random number for each one of our points. So that's kind of cool as well. So those are just some super basic things that you can do with the rand function. Let's mix this up with a few other functions and do something a bit more interesting. So you can remove this line of code and press Alt-E to bring up your string editor. Now what I would like to do is color certain points based on their frame number. So if a point is on a certain frame number, it gets a color while others don't. So to do that, we first need a random color for each point stored in a variable. So we say vector color rand equals rand, and then in here we'll say @ptnum, right? So this is what we did earlier. We know exactly what this does. It generates a random color based on the point number, and then it stores it in a vector. Earlier we were putting it to the @cd attribute. This time we're just putting it to a vector variable. Once we have that, we can also choose the frame that we want this to get its color at. So we say float coloring frame equals rand. And once again, we'll use @ptnum. Now the idea of this is to use this coloring frame variable, check what our current frame is, and if they match, then make the color of that particular point its color rand value. But the thing is, this is a value between 0 and 1. Remember, rand gives a value between 0 and 1. And now we want it to be based on a certain number of frames. So what we need to do is we need to fit this. So we say coloring frame equals fit, and then semicolon at the end, and we can fill in our arguments. Now, when you fit a range, what you're doing is you're taking a value. So in our case, we want to take our coloring frame, which is from 0 and 1. You take a value where you know the minimum value and the maximum value, and you fit it between a new minimum and a new maximum, and that adjusts our range. So if you have something between 0 and 1, and you want it to rather be between 2 and 5, then you use a fit function. So you say fit coloring frame. That is what we want to fit. Then you choose the minimum, which is 0, and the maximum, which is 1, because we know that this coloring frame is between 0 and 1. And then you choose your new minimum and your new maximum. So you say between 1 and whatever frame you want. So let's say 24. So now our coloring frame will no longer be between 0 and 1. It will be between 1 and 24. And to actually just check this, we can make a test attribute just called @test and make it equal to coloring frame, right? So if we apply and accept, and then go to our geometry spreadsheet, you can see that each of our points has this test attribute, right? And it goes from 1 to 24. So it's a random number from 1 to 24. Each point has a completely random number on it. And once again, if you want to see what this fit function looks like and what arguments it takes, you can go over to the Vex documentation. So if we go over here to our functions and then filter by fit, you can see that we have fit over here, and it says takes the value in the range from original min to original max and shifts it to the corresponding value in the new range, new min, new max. It gives us a float, and we can fit a value, which is also a float, between an old minimum and an old maximum to a new minimum and a new maximum. That's exactly what we've done over here. So we know the old minimum is 0, the old maximum is 1, the new minimum is 1, the new maximum is 24. So now we can move on. We can just remove this test over here, Alt-E to bring this back up. The next thing that we want to do is we want to say if the current frame, so @frame, and what we want to do here is we want to say if our current frame, so @frame, is equal to the coloring frame for this point, then change its color. So if the frame equals the coloring frame, then v@cd should equal that random color that we generated. So v@cd equals color rand. Semicolon. Note a couple of things. Remember our conditionals from the last tutorial. We have the if statement. Inside of the brackets is the condition. This is the operator. If this condition is true, then run the code inside of the curly braces. And then we also want an else statement. So we just say else, curly braces, v@cd equals set, and just make it black, 0, 0, 0, semicolon, apply and accept. Now, this isn't going to work, and I'll tell you why shortly, but I just want to show you that it doesn't work, right? You play it back and nothing happens. Why is that? Well, if you remember correctly from earlier, our coloring frame was a float. It was like 10.003, right? But there is no frame which is 10.003. If you go over here, you look at 10, it goes from 10 to 11. These are whole numbers in our frames. So what we need to do is we need to convert this to an integer. So we can use the round to int function. So over here, we just say coloring frame equals rint, round to int. And then we just put in what we want to round. So we say coloring frame and semicolon at the end, apply and accept. And now you'll notice that when we play this back, you get random colors until frame 24, because we fit this between 1 and 24. So if we had to change this, we could make this 1 and 240. And now when we play this back, we get these randomly generated points that are gaining color per frame. So press Alt and E to bring this back up. Now, one thing that I would like to do here is actually say in the else statement, instead of making these black, how about we remove them? So we say remove point, and this is once again a function. And in here, we say 0, comma, and then the point that we want to remove @ptnum. Now, what is this 0? We have this remove point function, and it seems pretty obvious, right? Just remove this point. But what is the 0? And if we go over to our Vex documentation, we can go and find it. So if we go to remove point, you'll notice that it says over here, geohandle is the first argument. And so what is geohandle? Well, it says over here, a handle to the geometry to write to. Currently, the only valid value is 0 or geocell. Don't worry about that too much. That sounds very convoluted. Basically, it is just the first input of your attribute rangle. Now, this might seem a bit weird, but oftentimes in coding, we start counting from 0. We go 0, 1, 2, 3, 4, so on. And that's the case over here. Our first input is actually input 0. And then the next one is 1, 2, 3. So it's 0, 1, 2, 3. In here, 0 is our first input. So that means our scatter points, right? So remove a point from the scatter points, so from our first input, whose point number is equal to the currently processed point. So basically we're saying, if the frame is the coloring frame for this point, give it a color. But if it's not, then remove the point. And as you can see, that's worked, right? You play this back, and you have these points. And all the other points are being removed. Now, for those of you who are very eagle-eyed, you may have noticed something. You may have noticed that our point colors seem to change towards red. And I can show you this with a copy to points. It'll become a lot more obvious. So you just drop down copy to points and just give it a sphere, right? So you put a sphere in here and copy to points. In the beginning, these points are all basically blue, but they slowly start moving towards red. Now you may be thinking, I thought you said that these are supposed to be random. So why is there a very clear progression from blue to red? The thing is, in our vector at the top, where we choose our random color, and then the float where we choose our random frame, we're using the same seed. So obviously the things that will appear will be matching. Because if it's the same seed, it's the same random number that's being generated. An easy way to fix this, which you'll see very often in a lot of tutorials and a lot of projects, is people often just multiply their point number, or whatever their seed is, by a random value. So 1, 2, 3, or just 12, whatever it may be, right? They say rand at ptnum, and any other time that you use rand at ptnum, you multiply it by a random seed. They apply and accept, and now it won't do that anymore, right? Now it'll be completely random every frame. Right, completely random colors now. There's no sort of progression of color. There's no pattern that it follows. So that's cool. But what we have is kind of boring. You know, I'm not going to lie, it's not particularly interesting. So what would be more interesting is if we change something in here so that perhaps the points get eaten away. To do that, all we have to do is say if at frame is less than the coloring frame. So now it just eats away. So perhaps this would look better on geometry rather than points. What we can do is we can bypass our scatter node. And over here on scatter node, it's the button to the far left, bypass, right? So it just ignores this node for now, and you can reactivate it just by clicking on that again. Ignore this node, go to your sphere, change it to a polygon, give it about 100 on frequency, and go down to your attribute rangle. If you play this back, you'll notice that this gets eaten away randomly. And perhaps you'd no longer want this to have a random color. So all you have to do is put 2 forward slashes at the beginning of the line. This is basically bypassing. This is what's known as commenting. It's commenting a line. And this is a useful thing to know because you can actually explain your code. So if you wanted to explain what this else statement is doing, all you would have to do is say over here, // this controls the else removal. Then perhaps after all of your variables have been initialized, you want to say above are all initialized variables, and you can start to understand your code better. And the thing about this is that comments are completely ignored by your code. It's like a bypassed node. So now we're ignoring color. And now if we play this back, it's a bit more interesting. You can also change things in your condition. For example, you could say if the frame is less than the coloring frame, and at p.y is less than 0. So now the top half is gone, and all you have is the bottom half. And we can adjust our frequency to just 80, maybe even 50. And what happens if you want this to eat away faster, so be done by 140? Well, we have our frame, our coloring frame maximum, and we can just readjust it to 140. Now, at 140, the last point will be eaten away. And then you could just give this a color, make it red or something, and you end up with a decently interesting looking effect. And the cool thing about this is that after this, you can do all sorts of things, such as using an attribute blur, and you can make this look very organic. Don't pin the border points, and you do it by proximity. Give it more blurring iterations. And then take a look at this. Right, all of a sudden, it looks really organic. And if you go to frame 1, you'll notice that there's holes at frame 1. All you have to do is change your range to be between 2 and 140. So it won't start until frame 2. Pretty interesting, right? Once again, giving it a higher frequency, and you can just play around with these things. So yeah, that's it for this tutorial. And if any of this confused you, I will go over all of the code down below. So go down there. If you have any questions, please feel free to message me. And I'll try and reiterate all of these functions as we go and all of these attributes. And so hopefully we'll develop a steady progression where we slowly develop comfort with Vex. And soon we'll be creating an effect using Vex, but that'll be coming after part 5 or so. So stay tuned for that. Once again, thank you for watching. Thank you for being a patron. I do appreciate the support. We will be back soon with part 4, then 5, and this will probably be about a 10-part series, and then we might have an extra few pieces at the end as a bit of a project. So thank you for watching. I'll see you next time. Bye.